Hello, and thank you for watching today. I'm John, and this is a presentation about my bachelor's dissertation in software engineering. It's titled Assessing Cybersecurity Threats Utilising Social Determinants and Machine Learning, and was supervised by Dr. John Henry, who is an expert in both machine learning and web development. I'll just dive straight in. What you're about to see is a presentation about the planning, design, implementation, and outcome of my work. So I hope you enjoy. Firstly, I'll tell you about the research area. This is the problem that exists in the first place to make this research worth doing. We live in a world where the rate of our technological progression has long surpassed the rate of our own evolution, and cybersecurity is definitely no stranger to this. What I mean by this is that when new technology becomes available to the whole population, it is often ahead of itself in terms of educating people on how to use it, particularly regarding how to avoid being exploited. In fact, SAS in 2001 claims that humans are the weakest link in the security chain. And this makes sense if you think about it. Software systems are built incredibly robustly, and access to data is often protected behind the latest encryption techniques. But to use software, we need human privileges that can unlock the necessary data. Therefore, if someone has access to sensitive data you want to steal, if you can trick them into downloading malware without them knowing, the data is essentially yours. Spear phishing is the act of sending emails to specific and well-researched targets while pretending to be a trusted sender. The aim is to either infect devices with malware or convince victims to hand over information or money. Spear phishing can have many different incentives, but it is always ultimately about stealing data. This research project, therefore, investigates which different threats are likely to work on which different people using machine learning techniques to find patterns between who a person is and how susceptible they are to trickery. The aims of this project, put simply, were to identify if social determinants can indicate potential security risks to systems by developing a data algorithm that assesses a user's social determinants and then indicates that user's potential security risk. The algorithm emerged from experimental data that I collected through an interactive training exercise tested on participants. To achieve my aim, I needed to research the signs and types of real phishing, use this research to produce some fake emails, one for each type of threat, recruit at least 50 participants to provide their demographic data, develop a test for participants to compare real and fake emails, and finally test and train the data in a machine learning algorithm. So after some research, the threats that I decided to test were authority, pretending to be someone's employer or government or so on. Urgency, stating that there is a limited time to click the link or else there'll be some sort of consequence. Reciprocity, claims that a favour will be provided to the recipient of the email. Social proof, suggesting that other people have clicked the link before. A reward, which is self-explanatory, that there is a false financial incentive to clicking the link. Loss, the receiver will suffer from a loss if they fail to click the link. Or finally, scarcity, that only a limited amount of people may click the link to attain the benefits promised. The following software development languages and libraries were used on this project. For the participant activity, we had Java and Java servlets on the server side. In the client side, it was HTML inside JSP files, Java server pages, CSS, so cascading style sheets for the styling, jQuery for the behavior, Ajax to send data from the front end to the server, JSPDF for the consent form. The environment was the Eclipse Enterprise edition for Java developers. For the database, it was simply MySQL using the MySQL workbench. And for the machine learning algorithm, it was Python 3.9 using libraries such as Panda, NumPy, scikit, missingno, and matplotlib. Moving on to the whole system design, I'll explain to you how the data passes from the front end, where the user is able to give over their information and complete the activity, through the server side, into the database, and then how the database can output a data set that the machine learning algorithm can work with and train on. Firstly, you have the mobile desktop client that needed programming, which consists of a consent form, the demographic information form, and the activity quiz. It was written in HTML, CSS, and jQuery. Next, you have the server side. The servlets are used as controllers between the data accessor object, which connects the server to the database, and also allows separate Java classes such as the participant class to store information about the participant in its own object, which is all coded in Java. You have the database, which was written in MySQL, and then you have the machine learning algorithm, which was written in Python, utilizing libraries pandas, sklearn, and matplotlib. So these are all the separate components of the whole system, but starting from when the participant will access the consent form, a fake name needs to be generated. This fake name needs to be unique because the primary key of the participant table in the database is the fake name. So the getSessionID class checks through the DAO that the fake name is unique, and if so, shows this to the participant in their consent form, so they know as they're signing that all of their data that they're providing as part of this research project is all stored under the fake name that they see there. Next, they give over as much demographic information about themselves as they're willing to share, which through the add participant servlet stores all of their information in a Java participant object, and this object, when complete, can be passed to the data accessor object and into the database. Next, you have their results from the activity, where they will have answered just yes or no as to whether they would have trusted each of the emails that they're presented with, and these results are then also passed to the data accessor object. And an optional feature of the activity is that users can leave feedback, which goes into the comments table of the database via the DAO. So the database is able to use views in order to prepare the data in a way that the machine learning algorithm can retrieve once it's been exported. I did this via a CSV. So this is how the whole design of the system was implemented, but also how the data flows between each component.